So just letting you know, I have started recording. I'm recording now. And yeah, I will go ahead and let me find the problem. So the first thing we want to talk about the problem is that it's talking about Evil Joe drops a person out of a plane flying horizontally. But the horizontal stuff doesn't really matter now, does it? Do you understand why that is?
No, not really.
Okay, so the idea is that horizontal and vertical, or rather perpendicular velocity, are kind of independent of each other. So the idea is that if they're dropping a person out of the plane, um, the person still has a horizontal velocity because it was traveling with a plane. It's just now that they have a vertical velocity too. Yeah. And later, when they drop the rock off, this rock also has the horizontal velocity as well as a vertical velocity. But the point that I'm trying to make here is that all three of these things, plane, rock, and person, will all be vertically aligned with each other, because they're all moving at the exact same horizontal velocity. Um, how do I explain this in terms of uh like, does that explanation make sense, or should I explain more? Because the rock and the person start having vertical velocities, but all of them have the same horizontal velocity as before. Can you picture
Yeah,
that?
that makes sense.
Okay, good. So that's the first insight of this problem, is that if you just do away with all of the other stuff, um, if you like, the first big insight of this problem is that you can ignore the horizontal stuff entirely and just talk about vertical components. And this reduces the problem down into a one-dimensional problem, which is really nice for us because that's a lot easier to think about. All that we have to worry about is the rock going downwards and the person going downwards. We don't have to worry about anything horizontal at all. Do you see that?
Hmm.
Right, good. So this is a problem where, to start about it, thinking about it, I just wrote down a couple of things. Um, I started making a note to myself of what I do know and what I don't know. So it's sort of implied by the question that Joe has what is it? Velocity vertical equal to 0 initially, right? It's saying that the nothing about the question indicates that Joe is being dropped downwards with any like initial push. They just are sort of falling at the start, and gravity does the rest. So that is to say, velocity Joe is equal to, let's say as a function of time, is equal to minus gt. This should be uncontroversial, right? This is just acceleration times time, and t is let's say t is the amount of, let's say that t is the time when Joe and the rock meet. So good so far?
Yeah.
Okay. So V Joe, what they tell us is that the rock is moving 10 meters a second faster than Joe when it passes by him. So let's just write an expression for V rock. And I'm also going to write it as a function of t. Um, Actually, forget that. I'm going to write neither of them as a function of t. I'm just going to say V rock at the time when Joe and the rock meet is, you can set it equal to two different things. But the very first thing is just using kinematic equation. We know that it's V naught times t minus 2 plus 1 half minus g t minus 2 squared. And so V naught is the unknown, because we don't know exactly what the initial velocity the person throwing the rock down is. We don't know how fast they're throwing it down. But t minus 2 is just this t minus 2 seconds because the rock only started 2 seconds later. But does this equation seem controversial at all? Like, this is your basic kinematic equation just describing the motion of the rock. Does that seem right? Or rather, the velocity of the rock. Does this seem agreeable?
Yeah, it does.
Good, good, good. So what we do know about VJO and VRock is that, what is it? VRock is equal to VJO It's saying it's moving 10 meters per second faster than Joe. So this is where we just have to be a tiny bit careful. I'm writing all of these velocities as negative. I'm treating initial velocity also as negative. So I would have to say 10 meters per second faster means minus 10 rather than plus 10. Is this controversial? Is this, should I explain this in any greater detail, or are you okay with the explanation behind my signs?
Can you go further into depth about that?
Yeah, basically every velocity I have is negative because I implicitly decided that upwards is positive in this problem and downwards is negative in this problem. So velocity of Joe is minus g times t. So it's basically going to be a negative number anytime t is greater than 0. You see that? And it's basically saying this downwards velocity, v Joe, negative. And similarly, v naught, I'm saying v naught is a negative value. And this minus sign here also has negative. So everything here is negative, right? Everything here is negative. So v rock is also negative. So we're sort of saying the faster you're moving, the more negative value your velocity is. And that's why this is minus 10 rather than plus 10. Good so far?
Yeah.
Okay. So this is going to be one of our equations. And essentially, in a moment, we're just going to plug this in. Well, rather, we're going to plug in this expression, and we're going to plug in this expression. And unfortunately, this isn't going to be able to let us solve yet because there's two unknowns, t and v naught, and there's only one equation. So the thing to do here is we need to find another equation involving these two variables. And we know from high school algebra that two equations, two unknowns is solvable. So we got to find that second equation. You kind of see the direction I'm going with this?
Yeah, somewhat. But I feel like once you go more, like show the two equations and two unknowns,
Right.
I'll understand better.
Great. Okay. So this was our equation for that we know about velocity. And the other thing that the problem tells us is, well, they meet each other. This t was defined to be the time when Joe and the rock meet. So let's also write another equation talking about position. Namely, let's call it x of the rock and x of Joe are exactly equal to each other at time t. So all we need to do is figure out how to write each of these expressions independently using kinematics. So x Joe should just be, well, Joe himself had no initial velocity. So this is just minus 1/2 g t squared. Yes, I believe this is just your expression for a falling object. And again, I'm using the convention where downwards is negative, upwards is positive, okay? Any complaints or issues so far that you'd like me to address?
No, I get it.
Okay. So at this point, x rock is going to be, what is this? Minus v naught t. I'm sorry. I messed up. This equation right here I wrote was actually for x rock. My bad. Sorry, this is, I'm sleepy and tired. This is actually the expression for x rock, right? V naught t minus 2, 1/2 minus g t minus 2 squared. The expression for v rock should just be v naught minus g times t. Right. Sorry, I just used the wrong kinematic equation. Just a total slip on my part. Are you okay with that? Yeah, this looks more like it, right? Velocity of the rock is just the initial velocity of the rock minus the acceleration times time. And x of the rock is minus v naught t minus 2 minus 1/2 times g t minus 2 squared. So is that equation I just erased because that equation actually describes the position of the rock as opposed to the velocity of the rock. I guess I'm just tired and got things mixed up. But are you happy so far?
Yeah.
Okay. So great. At this point, this we can set x rock and x Joe equal to each other. And we can set v rock is equal to v Joe minus 10. And at that point, we're basically going to be ready to solve because it's going to be high school algebra from there. But I'm going to write this out just to make things a little bit more explicit, right? This is v naught gt, v naught minus gt. Actually, this should be minus 2, right? Because the rock travels 2 seconds delayed. So v naught g times t minus 2 is equal to minus gt. This is equation number 1. And equation number 2 should just be, excuse me, there should be a minus 10 because of this minus 10. And equation 2 is just x rock is equal to x joe. So that's just saying 1/2 gt squared is equal to minus v naught t minus 2 minus 1/2 g. Why isn't my screen responding? T minus 2 squared. So these are our two equations. And our two unknowns are v naught and t. Two equations, two unknowns. We can solve this using high school algebra. Does that make sense?
Yeah.
Yeah, that's exactly the direction we go down. Now, some of the students earlier were a little bit nervous. I think maybe they were a little bit rusty with their algebra. But, I mean, once the hard part of these problems are boiling the physics statements down into cut and dry math, but the math itself is stuff that you've done before in high school. And as just a reminder, the way to do it would probably, if I was looking at this, I would probably just use substitution. I would try to isolate v naught, solve for v naught, and then plug that in over here. At which point, it's just a quadratic equation in terms of t, which should not be too hard to solve. In fact, it's not even a quadratic equation in terms of t. The t squares end up canceling out. But my point is, this should not be too bad. You should be able to go in there and solve for both v naught and t explicitly. Yeah. When is this due, by the way? Is it like one of those things where the due date is depending on when you open it up?
Yeah, it is.
Okay.
But it's not due until tomorrow.
Okay, I see. Well then. Yeah. Do you think that about covers what it needed to cover? Or do you have any further questions? Yeah, and sorry about making so many tiny arithmetic mistakes or just using the wrong equation. Guess I'm just pretty exhausted right now. But go through the argument yourself, because, well, the point of this teaching exercise is to show you the general outline of what problem solving looks like, but you got to be able to solve the problems yourself on any exam or quiz. Yeah? So go through, make sure to check that I didn't make any sign errors or use the wrong equation anywhere else. But this is the big idea. You have two unknowns, and therefore you want to find two equations. And they give you, in the wording of the problem, they tell you there are two equalities in here. One between the positions and one between the velocities. Velocity minus 10. Yeah, and that's basically it.
Okay, thank you.
Sure.
I appreciate it. Have a good one.
Does anybody else have any other questions about this? Okay. If there are no other questions, yeah, I guess that's that. I will wrap up recording.